Hey everyone, and welcome back. This is the last lesson in our Unit 6 Exponential Functions and Logarithmic Functions folder. So we're going to talk today about just solving different types of logarithmic equations using those properties of logarithms. I'm going to throw some challenging ones out there at you, but for the most part, I think you guys will find this pretty simple and straightforward. All right, objectives today: simplify and then solve. So essential questions: what are some strategies you can use for simplifying a logarithmic expression? And then what are some general steps maybe that we can think of for solving? So is there like a 1, 2, 3 process that you can kind of go through in your head for trying to solve some of these? Last video we looked at graphs, we identified transformations and key points, and then we talked about things like the vertical asymptotes, domain range, and rate of change. Okay, so let's get straight into it. Simplifying. I talked about this in our last video a little bit, but if you have something like log base 2 of 16 to the power of 3, so a couple of things we can do here. We know that the power property means that the 3 will come to the front, so it'll be 3 times log base 2 of 16. And we can ask ourselves, like, 2 to the power of what is 16? So like, can I evaluate this? If I'm not sure, what I can say is this is 3 times log base 2 of 2 to the power of 4. So that would cause the log base 2 to cancel and the 4 to come down to the front as well. So we'd end up with 3 times 4. Now, I'm guessing for most of you, like, just evaluating this is easier. Like, log base 2 of 16 is just 4. So 2 to the power of 4 is 16, and then 3 times 4, our final answer is 12. So being able to simplify logs is going to be a helpful tool for you, particularly when we start solving. All right, same kind of question down here, log base 4 of 256 to the power of 2. So we've got 2 times log base 4 of 256. And then 4 to the power of what is 256? Now that's where it might be like, I have to go do a little bit of guess and check. So I believe it's what, 4 to the power of 5? Nope, 4 to the power of 4. Yep. So that's 4 to the power of 4. So 2 times 4, which is 8. That's it for simplifying. Just like, that's all I really wanted to kind of draw attention to, was just like, okay, watch out for these couple of things. The next one up is solving. This is really what the majority of this lesson, if we're going to call it that, is about. Looking for different ways that you can solve these logarithms. All right, so for the first one, couple things to look out for. And this is really where practice is going to help you a lot. It's 2 times log base 7 of minus 2x equals 0. Couple of things. You can't do a log with a negative number up here, because like 7 to the power of anything is not going to equal a negative number. So that means that x must be a negative number. So a negative times negative is a positive. That makes the whole logarithm positive. So just a couple things to watch out for. Second one, it's equal to 0. So if I try and simplify this down, I divide by 2 on both sides. I mean, 0 divided by 2 is still 0, so I'll end up with log base 7 of minus 2x equals 0. So the question is, 7 to the power of 0 is equal to minus 2x. Well, this is, I'm converting to exponential, by the way. 7 to the power of 0 is just 1. So 1 is equal to minus 2x. Put that minus 2 across. So that means x must be negative 1/2. So you're using your laws of logarithms to try and evaluate this down. Next one up, minus 10 plus log base 3 of x plus 3 equals minus 10. So it's minus 10 on both sides. If I add 10 to both sides, it's going to be equal to 0 again, which I'm like, yes, that works. So once again, 3, if we're putting this exponential format, 3 to the power of 0 is equal to x plus 3. 3 to the power of 0 is 1. So then subtract 3 from both sides, x equals negative 2. Now, one thing that will come up soon is this idea of extraneous solutions. So like, say I took that x minus 2. If I put minus 2 in here and say this was a 1, and it ended up being log base 3 of minus 1, well, that's not possible. So that would be considered an extraneous solution. So we will, at some point, have to start checking our solutions. And I recommend you get in the habit now, particularly when we start getting like quadratics that we're solving to find two different values of x. Sometimes one of them is extraneous. We'll check that and see. So we might actually get one of those here. So ln of x squared plus 12 equals ln of minus 9x minus 2. Since there's an ln on both sides, that part's equivalent. So we can just divide that out, cancel it out, whatever you want to think of it as. We're left with x squared plus 12 is equal to minus 9x minus 2, which is just going to end up being a quadratic for us. Get it all to one side. So we get x squared plus 9x plus 14 is equal to 0. So x is equal to, or x plus 7 and x plus 2. So x equals minus 7, x equals minus 2. And we just check both of these to see, like, is it a realistic thing for both sides? So minus 7 squared is 49 plus 12. I mean, that's going to be a positive number. And then 7 times minus 9 times minus 7 is positive 63. Minus 2 is 65. Still working out there. I'm sorry, 61. And then minus 2 squared, fine. Plus 18 minus 2 is 16. So it's still going to work out as positive numbers. So happy with both of those. All right, your turn. Pause the video and come back when you are ready to see the solutions. All right, so we have log of x plus log of 8 equals 2. So remember, log is a common log. It means it has a base of 10. So these both just have base 10. If we see two logs with the same base added together, we can multiply. So that is log of 8x is equal to 2. So then thinking about it going to exponential form, that would be 10 to the power of 2 is equal to 8x. 10 to the power of 2 is 100. So 100 is equal to 8x. So 100 over 8 is equal to x. And let's see, that would be 12.5, I think. All right, so then moving into second one. Both log base 10s, so they're equivalent on each side, which means that we can just take the part inside the logarithm, put it equal. So we're going to get that quadratic scenario again. Bring it all to one side. So we get x squared minus 6x minus 16 is equal to 0. So that would be x minus 8 and x plus 2, which means x is equal to 8 and x is equal to negative 2. If I sub both of those in, 8 times 8 is 64, minus 32 is still 32, and 16 to 16, 32, so 8 works. And then minus 2, we would have 16 minus 4, which is 12, and we'd have 4 minus a negative, or minus 4 times minus 2, which is a positive 8, so we'd have 12 again. They match, they're both solutions. All right, we have log base 8 of 2 plus log base 8 of 4x squared equals 1. So they have the same base. We can go from there. It means we're going to multiply the two of them together. So it's going to be log base 8 of 8x squared equals 1. Now this might be a scenario where it makes sense to actually separate them again, because like log base 8 of 8x squared, I don't know why I put it equal to x, equal to 1. So we could do actually, there's no need to, because think of it this way. 8 to the power of 1 is equal to 8x squared. So putting it into exponential format. So 8 power of 1, 8x squared. So that means 8 is equal to 8x squared. So 8's cancel down. We're left with 1 is equal to x squared, which means plus or minus 1 is our value of x. And both would work in here since it's a squared anyway. All right, here's a little challenge for you. Solve for the value of x, but keep your answer in terms of e. So that means don't put it in your calculator and evaluate it. Keep it in e format, because remember, e is an irrational number. So if we evaluate it out, we're going to get decimals. So keep it in terms of e. Take a shot at it, pause the video, come back when you're ready to see the answer. All right, so like the last one, we had two logs with the same base. This time it's just e. They're subtracted, so this is going to be ln of 2 over 3x plus 2 is equal to 1. So remember, if they're subtracted, you divide. And then we've got ln of blank equals 1. So that would be, remember, log base e of 2 over 3x plus 2 is equal to 1. So going into exponential format, e to the power of 1 is equal to 2 over 3x plus 2. So now we've gotten rid of the logs, we're back in exponential, and e to the power of 1 is just e. So we're able to work with that. We're trying to solve for x, so we got to get the x out of the denominator, multiply by 3x plus 2 on both sides. So then 3x plus 2 times e is 3x e plus 2e is equal to 2. We want x on its own, so we can subtract 2e from both sides. So we'll get 3xe is equal to 2 minus 2e. And then to get x on its own, divide by 3e on both sides. So our final answer, x is equal to 2 minus 2e all over 3e. So that's your answer in terms of e. We're not going to evaluate it. Like we could type this in our calculator. E is an actual number. It's a natural number. It's an irrational number, but it is a number. So we could get a decimal answer for this, but we don't want one. We want it in terms of e. So if you got it, congratulations. If you did not, maybe think about, okay, where did I get lost? What can I do differently? All right, that brings us to the end of our lesson and the end of our unit. So we've got strategies for simplifying logarithmic expressions, thinking about, if I've got log to the base of a number of a value, is there a way to rewrite that value in terms of the same base so we can start canceling out and get an exponent out? You can start experimenting with guess and check on your calculator too. Steps for solving, like trying to get the ones with the same base together, looking at converting between exponential and logarithmic form to see, like, is there a way forward using any of those strategies? You get better with this with practice. Like, that is the key. Like, it's not a quick fix. It's not going to sometimes come to you very quickly. It's going to take some practice and some time, and you will have plenty of opportunity to practice. So with that, make sure you complete the folder. You've got math tests, a checkpoint, and a unit test to complete. I'll see you in the next unit.